we have Dana from Watershed Consulting Associates and Rachel Beauregard from Agency of Transportation in Vermont. This is the fourth part of a 6-part series in the webinars. It's based on the manual that was developed for the Basin program by Watershed Consulting Associates and Hirschman Water and Environment. So thanks to Dana there at Watershed Consulting Associates and Dave Hirschman at Hirschman Water and Environment. And I think I'll go ahead and hand control over to Dana and let him take it away with an introduction.
All right, thanks Ryan, I appreciate that. Yeah, so like Ryan said, we're going to be discussing green infrastructure for municipalities in New York's Lake Champlain Basin, focusing on practices that can help control the water quality pollution effects of rural roads, which make up quite a bit of the Lake Champlain Basin in New York. So I'd like to thank the Lake Champlain Basin program and NUEPIC for funding this project, and as well as Dave Hirschman from Hirschman Water and Environment for collaborating with us on this. So to kick it off, we'll try to keep this moving right along. First off, the manual download. We spent a lot of time on this manual. It's pretty slick, so if you haven't already, you can download the manual from the LCBP website. I know that's quite a long URL. You may just want to go to the LCBP website and search it out. It's pretty easy to find. You can also view all these past webinars on YouTube. We post them up pretty quick right after the webinar finishes, usually within a few days. Ryan's been right on top of it. So if you go to that URL or just search Lake Champlain Basin Program YouTube, that'll pop up as well. The other thing that you may be interested in is you can download the New York Rural Roads Active Management Plan Manual, or RAMP manual. Always makes me think of springtime riverside vegetation ramps. The best URL I found for downloading that was actually the Warren County Soil and Water Conservation District. They've got the whole PDF right there. It's very closely related to the Vermont Better Backroads Manual. In fact, it was based on that manual. So you may want to grab the Better Backroads Manual as well, just as a supplement. But those are your sort of base resources for these rural road management practices. So without further ado, we'll jump right into what we're going to be doing today. So first off, we're going to give you an introduction to rural roads, what are the issues, that sort of thing. We're going to look at those issues, so pollutant issues associated with rural roads. We're going to look at opportunities and challenges, and I started with opportunities because I wanted to be positive about this, because there are a lot of challenges, but there are also a ton of opportunities. We're going to look at the auxiliary benefits of not just water quality benefits, but also infrastructure benefits. We're going to go briefly through the practice selection as it's sort of laid out in our manual. We give a number of practices that you can use. Then we're going to talk about a couple case studies in Vermont that have been featured using Better Backroads practices. So they're Vermont case studies, not New York case studies, but they're very applicable to situations in New York as well. And then we're going to look at our featured case study, which Rachel is going to present, and I believe it's located in Charlotte, East Thompson's Point Road. So and then once Rachel's done, we're going to have a little bit of time for questions, do maybe a little quick poll question here and there for the audience, and then do a summary of everything that we've learned. And then there's going to be a lengthy quiz. Just kidding. No quizzes today. So here's your intro. First off, why are we even talking about these rural roads? Gravel is pervious, right? That means stormwater will go into it. No, sadly, that's not the case. I've talked to a lot of people. They say, well, why do we have to manage these roads? Water just infiltrates. It absolutely doesn't. As you can see from this giant piece of machinery, gravel roads are way too compacted. This is fundamental to the way the roads are built. So it's good for the roads, good for travel surfaces, but bad for infiltration by design. So that's kind of one of the first things about gravel roads and rural roads that we need to talk about. Second thing is that this is a little map of the Bolton area. You can see there's a lot of little tributaries in here and some steep side slopes, and here are these roads coming right up these valleys. There are probably a lot of unmapped tributaries right in through there. Here's one, crosses down through these driveways in this road. There's a trib right there. There's actually an unmapped tributary right there. So these rural roads are often built in steep areas next to small streams, where an increase in runoff volume and sediment loading can have a big impact on small streams. And so that's one of the reasons that we're concerned about these things. So we'll just do a quick poll question. We don't have to spend too much time on this, but I'm just curious, does your community have these types of roads, and do you have frequent erosion issues with them? And you can type your answer right over here in the chat box. You should be able to see that. We can look at that. I'll chat back to you. Ask any questions you'd like. If we don't get any questions, no big deal. We'll keep moving. But I'm just curious to see what issues other communities are having and if this is something that really affects them as well. So, moving on to the next thing, rural roads, stormwater issues. So what are the common issues associated with rural roads and their stormwater? So some of these are very analogous to developed roads. So we have a lot of hydrocarbons and heavy metals from cars, so incidental leaks, that sort of thing that are going off onto the road surface. But that you'll find pretty much anywhere. So that's sort of just associated with roads generally, not necessarily just rural roads. We also have the issue of organic deposition. So we get a lot of organic matter like leaves and grass clippings and like that on the road surface. When that accumulates, it's not going to infiltrate like it would in a nice wooded area. So you can see over here, all those leaves, they'll eventually decompose and go back into groundwater. All these leaves on the surface here, they're eventually going to decompose. They're not necessarily going to go back into groundwater. They're going to run down the ditch and into the nearest stream. And so that's not really something we want. Oh, I'm going to mute Dave. So that's kind of the two issues that, those are two common issues to any street. But then there's some other issues that are associated with rural roads that are not necessarily common to all streets. So road surface erosion. So in a paved road, you won't really have this, but the road surface of a rural road, especially, a gravel road, they can erode over time. There's phosphorus bound up in that material. There's also the fact that this is just sediment load going into these smaller streams that can choke the stream out and wreck the cobble bottom that's in there. So this is something that we have to pay attention to, is the fact that the road itself can be a pollutant. So you can see right here, it's pinned right against this big river. River's looking pretty gnarly, kind of like chocolate milk. You also get road shoulder erosion. So even though this isn't part of the traveled road lane, you can get road shoulder erosion happening right into the ditch, and then the ditch can convey it directly to these smaller streams or larger water bodies. And then you also get ditch erosion. So those are the three areas where you see a lot of issues associated with roads. And so basically all the practices that we're looking at are going to try and figure out how can we stop this sort of erosion, how can we stop this sort of pollution. The other thing that happens with these rural roads is that we get flow increases. So picture this nice little river valley before, some little, steep tributary valley that's got a lot of trees, got a lot of duff on the ground, the surface is pretty rough. And then we decide, all right, we got to get up there to, go to a ski area. So we've got to put in a road. So we put in this road. So now all that water is going to hit that road, and it's going to get conveyed into the nearest downstream point or lowest point, so probably a small tributary. And it's really going to increase the flow in that stream. That's going to cause a lot of changes there. It's going to start scouring the stream bed. It's going to start making the stream move side to side, so stream geomorphology changes. And that's due in part to that change in hydrology of the watershed due to that road. So as you can see, this is sort of the classic curve. Here you've got this pre-road development, nice, gentle hydrograph. So it's kind of coming up fairly slow and then tapering off fairly slow. Post-road development, we see a lot of these peaks where you hit a pretty high peak pretty quickly and then tapers down. So this is one of the big issues that we have to deal with. It's kind of common to all development, but it does occur with these rural roads as well. So something to keep in mind, that flow is also a pollutant. So we do have opportunities. So in addition to the challenges, these issues that we just sort of pointed out, we do have the opportunities in that typically there's more open space to work with in these areas. So we can actually install practices outside of the road right of way. sometimes you can only locate practices within the road right-of-way. That's a little bit more difficult. So then if you've only got like the shoulder and the ditch to work with, then you're sort of constrained as to, you know, what kind of erosion control methods you can use, whether it's stone lining or any sort of sedimentation basins. But sometimes with these rural roads, you're far out in the back and beyond. There's nothing around the road. You can create larger turnouts, larger infiltration basins or sediment basins. So you can have a lot of options that way versus more developed roads in urbanized centers or village centers where there isn't as much space necessarily. And oftentimes these practices are simple to install. So, you know, picture sort of a very ornate bioretention practice in an urbanized center. There are going to be a lot of utilities to work around, pavement to rip up, sidewalks to move, curbing to install, maybe a lot of outreach. With these rural roads, in addition to potentially having a lot of space, you may not have to do all this additional utility investigation. You may not have to rip up a whole lot of ground. You can often do things just as simple as stone armoring of ditches or adding stone check dams within the ditch flow line. Even sometimes things as simple as road resurfacing, so regrading the surface, adding better material, making sure that water sheets off the road surface more efficiently. These are all the sorts of things that you can do. Regrading ditches is another one. So relatively simple work can have big benefits down the line. However, there are some challenges associated with this stuff. So these roads are often remote. So when we're talking about bringing in stone for armoring and check dams or material for road resurfacing, you've got to get that material out there. And as anyone who works in contracting or design will tell you, it's not the material that's expensive, it's the transportation. Diesel is not getting any cheaper. Trucks are not getting any cheaper by the hour. So getting that material there to actually do the work can be the biggest challenge. So you have to be somewhat judicious when you're looking at doing some of these practices. You know, specking 1.5 miles of stone armored ditch sounds really great from an erosion control standpoint, but from a material transport and cost standpoint, that could be a project killer real fast. So that's one of the challenges. These roads are often steep. So constructing things on steep slopes, again, not an easy thing, especially when you've got a road crossing steep slopes. You may have a steep downhill slope with a really steep road back slope. So ditching in that scenario or installing any sort of infiltration practice or a sedimentation basin, that's going to be very difficult. So, you know, that's one challenge that's commonly found with these practices. So you can be constrained by steep slopes on both sides. So it's pretty hard sometimes. But, you know, that's the way it goes with these roads. You gotta overcome these challenges as best you can. There are auxiliary benefits. I just love this photo. It's like the best rural road I've ever seen. Look at it. It's a beautiful crown. It's got nice road shoulders. It's probably Europe. I don't know. It just looks wonderful. I wish all our roads in Vermont looked like that, and New York. But anyway, let's talk about the auxiliary benefits. These practices that improve water quality can also improve road durability and resilience. So basically what we're driving at with a lot of these practices is we're trying to reduce the amount of erosion that occurs on the road surface, on the road shoulder, and in the road ditches. So if we're not eroding those three areas, that means our road is sticking around for a lot longer. We're going to have a longer lifespan, a longer usable lifespan of that road. So you're protecting your infrastructure. You're protecting that road surface. You're not going to have to bring in material. You're not going to have to regrade it as frequently. Your culverts will last longer. There's always the classic culvert. You know, it's an 18-inch culvert and it's 3/4 full of sand. Well, it's not an 18-inch culvert anymore, and you're probably going to have to blast it out, or maybe even replace it entirely if it's gotten hammered to the point where it's not usable anymore. So if we can protect that infrastructure, that means we have to spend less on that infrastructure. So that's great from a life cycle cost. And again, you know, less material will be needed for road reconstruction, just like we just talked about. Getting material out there is really hard sometimes in some of these more remote locations. So basically making it last longer is going to reduce your costs overall. So now that we've talked about some of the common issues, the opportunities and challenges associated with rural roads and the auxiliary benefits, we're going to kind of dive into some of these practices. What we've done in the manual is we've laid out a decision tree for each of the environments that we designed for, and one of them obviously is rural roads here. So when you're managing a rural road, you can use this flow chart to figure out, all right, what are my options? So you start up here. This is what we're doing. We always start with impervious cover reduction and preservation of natural features. The manual is almost like a broken record on this. We talk about it in every chapter, in the intro to pretty much everything. Why is that? Well, if we don't create that much impervious cover, or we preserve potentially beneficial natural features like low gradient vegetated areas or trees, those suck up a lot of water. So if we're not creating that much runoff and we're allowing for the most absorption of that runoff by those two things right there at the top, then that's a good thing. So that's kind of where we start. So then we start looking at, well, do we have a confined or an unconfined area? And that starts to dictate what we can do. And there's a lot of choices to make here. I'm not saying that this decision tree is the be-all and all of decision making as far as practice selection goes, but it's a good place to figure out, all right, what are we generally looking at? You know, so if you're confined, you may be working only in the road right away. So then you're looking at road surfacing, stone armored swales, check dams, maybe just water bars. If you're somewhat unconfined, you know, you can go outside of the road right away. You can start working in maybe private property or just a little bit outside of the road right away. Then you can start talking about doing like some sort of bioretention or infiltration practice, sedimentation basin. You can do things like culvert outlet plunge pools or stone armored turnouts. So that's something that you can start to look at to see, all right, what are my choices there? So like I said, if it's confined, you'll be working on the surface or in the ditches. If it's not, you can install practices outside the road right away, like those turnouts or plunge pools or other practices. So basically look at this as your starting point. So go there first, kind of figure it out, and then start to look at the actual practices. So we'll start to go through the practices that we outlined in the manual. Again, this is kind of a brief overview of a lot of different things. So we'll start with outlet protection. What we mean by outlet protection is basically the end of any culvert or sometimes a swale. Essentially doing some sort of rip wrapping. So here's your conveyance. There's your rip wrap. Basically, you know, these plunge pools can look like this. They can also take the form of these channel rip wrap practices. So essentially what you're doing is you're capturing that water, you're hardening the surface, you're dissipating the force within that angular stone, and you're letting it spread slowly out into this nice little happy vegetated area where it's not going to erode anything. It's going to infiltrate into the groundwater as it would have naturally. So you're just giving the water a chance to do what it would have normally. There's a lot of different design requirements for this. We don't go into this heavily in this manual. We refer people back to the ramp manual. But there are some things that are, you know, fairly easy to do. So if you're looking at the distance between culverts and it's a crown road or a banked road, we can kind of give you some general guidelines on the cubic footage of the plunge pool. If you want to get really into it, you can start modeling these drainage areas and that sort of thing to really get down to the nitty-gritty. But for a general idea, we give you sort of this overall guideline to go with. So that's outlet protection. One of the most common things that we recommend when trying to improve the condition of rural roads is road surfacing. That's really important. And right here we're showing a typical crowned section. Roads don't always have to be crowned. So by crowned, I mean basically there's a higher center point and a lower shoulder tapering off to or a lower travel lane tapering off to a lower road shoulder. Sometimes roads can be in or out sloped, so the entire road will be angled towards the road shoulder and a ditch in one direction or the other. But that's just to sheet water off the road. This is one of the most common things, because as long as you're getting water off the road in an even fashion to hopefully what's a low gradient vegetated area, see that's a 4-to-1 vegetated slope, so fairly flat, then you're not dealing with as much water. You're not concentrating flows. You're not conveying it to a downstream point. So this is really critical. One of the biggest things that we see with road crowning and road maintenance is these grader berms. So they'll come back through, it's been plowed all winter long, a lot of material's been moved, you'll get these little grader berms on the edges. They'll block water. So instead of water getting off onto this nice shoulder, it's going to run down the side of the road. This starts to eat the road away, and over time you start to develop runneling in the road. These are kind of wheel ruts. That's not as bad, but you often see roads where it's really deep, really severe. So even just shaving those down is a huge thing in terms of making sure that water sheets off the road. So basically the road surfacing benefits are, sheds runoff better, it reduces the risk of erosion. You can also add better material. This is usually quite expensive. There are products out there called SurePack or Stay Mat. They go by a bunch of different names. It's basically a gravel with a lot of fine particles mixed into it so that it locks together a bit better like pavement. It isn't pavement, but it's a little bit cheaper to install, seems to hold up fairly well. So that's something that can be done, especially on steeper roads or for smaller sections. Doing an entire network of roads with it is really cost prohibitive generally. So you have to be somewhat judicious in its use, reserving it for those high impact areas. So that's one of the practices we talk about. Now we'll go on to everyone's favorite practice, stone armoring. Possibly one of the most effective, but maybe one of the more overused practices out there. Stone armoring essentially refers to putting lots of rocks in the ditch. So you start out hopefully with a nicely shaped ditch. So not a V shape, but a nice U shape, fairly flat bottom. We usually recommend 1 foot to 2 feet minimum for a flat bottom with fairly gentle side slopes, 2 to 1 or less. And then you armor it with these large angular stones. You can do things like grass lining ditches. You can see in this table up here, 0 to 5%, you can usually get away with grass lining. But then when you get up above 5%, you're really into stone armoring those ditches. And what this does is it hardens those surfaces so it prevents erosion within the ditch. It also serves as an important filter. So it filters out sediment via entrapment. So basically, the sediment gets trapped in all these little holes down through there. So it doesn't get transported. So maybe you're still transporting a lot of water, but it's at least cleaned of a lot of those larger sediment particles. So you're not transporting as much downhill. This is a favorite practice of a lot of road crews. It's also definitely very overused at times. It can get quite expensive. So I think that as we, as a stormwater management community, go along, we really have to start looking at where can we more critically put these practices and how can we do it so it's a little bit more cost effective. One of the big things to go along with stone armoring too is that you do have to maintain it. Over time that will fill up with sediment, and how do you maintain that? I have yet to find a definite good answer for that other than outright replacement or washing it on site. So that's something that we as a community are trying to figure out. So, and that may be something that you are also trying to figure out in your community. And I think we're all kind of on the same boat in that we're experimenting a little bit. So again, don't use it everywhere that you don't have to. There are other things that you can do. One of the other things that you can do that I actually like quite a bit are stone check dams. So stone check dams are basically a big pile of rock. There's a little bit more to it than that. This is actually taken from the Vermont Small Sites Guide, and we put that in the manual just because it's a very easy illustration of what a check dam is. The ramp manual has a more technical diagram of that, which Rachel may actually show during her presentation. But basically what you want it to do is pile up this rock and then put it in the full span of the ditch. So it has to go across the full span of the flow line. So this is a ditch that's just recently been redone. They put some erosion control blanket down, and then they've made these rock check dams across the flow. Not sure why they didn't plant this yet. Maybe it was a fresh project. I don't know. I'm not sure I'm comfortable with that, but that's all right. It's just a picture. So anyway, we're looking at basically a practice which will trap water behind it, pool it up. The water will slowly move through these check dams, and the particles will end up back here, so all filtered out. What's nice about this is you create finite areas of particle entrapment. So you can imagine right back here, that's going to be where most of the sand and sediment is. That's relatively easy to clean out compared to, say, an entire rock-lined ditch where it's all spread relatively evenly throughout that ditch. So that's something that, you know, could be useful for certain areas. We do put a quick little table in there regarding spacing. Again, that can be adjusted based on conditions. So this is a really beneficial practice that's actually relatively simple to install, and we're seeing more and more of them in Vermont, which is great, and hopefully in New York as well. One thing that's very interesting are water bars. So essentially something that can be installed on the surface of the road that breaks up the overall drainage area. So if you can imagine this is all the surface flow coming down the road. Now before this water bar was installed right here, it would have just kept going down the road, picking up more velocity, picking up more volume, eventually causing more erosion. But now what they've done is they've interrupted it with this little water bar rolling grade reversal. So water is going to get trapped in there. It's going to get shunted off to the side of the road into the ditch. Hopefully the ditch is nice and stable and doesn't go right into a wetland or a stream. And you've kind of made this little bump on the backside, so it kind of further ensures that it's going to trap that water and redirect it. Cars are still able to roll over these. They're very gradual, but it does redirect the water. Another type of water bar are these trenches. They're basically like a box trench. So it does the same exact thing as this rolling grade reversal, just in a vertical walled box trench. They both will require maintenance over time. They're going to fill up with sediment. They're not going to convey water as well, but they will work for a fairly decent amount of time depending on the erodibility of the road. So it's nice because, you know, you're getting water off the road surface in a very defined sort of way, and you're breaking up the road into smaller drainage areas or smaller segments. So those are some of the practices that we go over in the manual, and then we highlight a couple of case studies. So they're both Vermont case studies. One is from East Burke, Vermont. It's a project that my company actually worked on, where we basically looked at creating turnouts, doing some stone armoring of the ditches, and doing some road reshaping. And in the manual, we talk about this in a little bit more detail. We're going to skip over that today so that Rachel can give her presentation. And there's another one from the Mad River Valley in Vermont, doing some stone armoring, a road reshaping, and impervious reduction. And that's actually a really great project that's really close to where I live. So that's a nice one. So, got another poll question for you. Basically, if you guys want, look at these. Which one of these practices would you be most likely to implement and why? So type your answer in the chat box. Again, I'm just curious to know, would you be more interested in like something like road outlet protection, where it's off the surface of the road, seems to be pretty easy and finite for a crew to deal with? Road surfacing, where it's more holistic change of the road network? Do you want to stick with stone armoring? It just works, it's easy. Stone check dams, is this something you've done or maybe not something you're interested in? Or something like these water bars. These are by no means all the practices, and Rachel's going to go into a lot more practices, or at least touch on a few of them in her presentation. But yeah, type your answers in the chat box. We'll kind of compile those, check it out just out of curiosity. But without further ado, I would like to hand this presentation over to Rachel. She's going to be talking about Vermont's Better Backroads Manual and how it relates, or not really how it relates, but that's what the RAMP manual is based on. And she's going to be doing a quick case study as well. All right, and Rachel, I'm going to switch it over to you.
Perfect. All right. So thank you to Dana and Ryan for pulling this all together. I'm Rachel Beauregard. I work in the V-Trans Better Roads program. I've been doing it for about 3 years. I've been with the agency for about 8 years. So we've got a lot of experience with these sorts of projects, all with pretty successful results. V-Trans and the Better Roads program is a newer partnership. The program's in its 5th year at V-Trans, but we feel it's a very great fit. V-Trans, their strategic goals and agency-wide objectives really match up with what we're doing in the program. The agency is hoping to preserve, maintain, and operate the transportation system in a cost-effective and environmentally friendly manner and minimize the environmental impacts of the transportation system. So everything we do in our program matches right up. Funding for the program has really gone up in the last couple of years as well. We used to have about $300,000 for the program. Now we're around $3 million. We're funding about 225 projects each year. And we have 4 grant categories for our program, ranging anywhere from an $8,000 planning grant all the way up to $40,000 projects for bank stabilization, culvert replacements, those sorts of things. So the guiding principles of our program, the goals, we're hoping to save some money on maintenance, provide lasting fixes to erosion issues, and enhance and protect the water quality in Vermont. We do this by getting water off the road quickly, stabilizing and revegetating disturbed areas, diverting runoff and sediment from our surface waters, hopefully decreasing maintenance and repairs by doing all of these items, and hoping that that good maintenance really reduces the susceptibility to flash flood damage around the state. All of these projects really take a lot of work to do. It's not just our municipalities that are working on these. Between VTrans, all of the other regulators around the state, a lot of our towns involve their community members. They have local volunteer groups and organizations, watershed groups, those sorts of things. Really, property owners are another key to these projects as well. Without them, they wouldn't be able to turn the water off the road. Getting the property owner to understand why the project is going to save not only them money, but the town money as well. Really key. So I'll get a little into the best management practices we encourage our towns to use. All of these are available, as Dana was saying, in the Vermont Better Roads Manual. There's the link below on the bottom of your screen. The best way to get to that, I just encourage people to Google Vermont Better Roads, and it'll bring you right to our website. And the manual is right there. So a lot of our projects we see are ditch installation projects. These are a couple we have around the state, both in Groton and Eden, Vermont. Groton's project was done just last year. Eden's was a couple years ago. Both of these towns did stone line their ditches because they were on steeper slopes. As Dana was saying, generally between 5 and 8%, we encourage them to think about whether they need stone or not. Anything over 8%, they should be using stone. The reason for that is just with the soils, by the time you get to that sort of slope, if you get a big storm, all of the soils are going to erode away. So the diagrams we have in our Vermont Better Roads Manual, those are ideal, but we encourage our towns to adjust according to field conditions. They may encounter ledge, there's trees in the right-of-way, all sorts of other things where they may not be able to get that ideal condition. We also encourage them to use vegetative measures wherever possible. A lot of our road foremen have been here 30, 40 years. They try to stone line ditches no matter what, and that's really not going to be the best solution all the time. It's going to cost them more money on maintenance. In the long run, it's just not as good of an idea. We also like them to seed and mulch at the end of each day. If they can, we encourage them to use a hydro seeder. A lot of our road foremen actually work together and their towns share the hydro seeders. It's worked very well. Hydro seeders, we think, actually encourage that growth, and growth can happen a lot faster. We also encourage the towns to work from the top of the hill all the way down to the bottom. The reasoning for that is if a storm comes, you don't want your whole project washing right into what you've just worked on. And the stone size really depends on what flow they have coming through the ditch at a given point. We want them to look at what's going on out there. If they don't hire an engineer to size things, we like them to see in a large storm what sort of water is coming down. We don't want them putting stone in that's too small so that it's going to end up all the way at the bottom of the ditch. But we don't want them putting in stone that's too large either so that the water is running completely underneath everything during a storm, or that you're just going to fill the whole ditch up with stone. Bank stabilization is another group of projects that we encourage, whether that be on a lake, through a stream, or just a bank that's unstable above a ditch. And these are all Better Roads projects that have been completed in the past. So just like we do with any other BMP we have, we really encourage the use of vegetation. Stone should always be a last resort. Your plant selection is going to make a huge difference here, so make sure you're choosing plants that are really vigorous growers. They have long, aggressive roots so that they're really getting into that bank and taking hold of the soil. And any above ground growth, we try not to make it too large or heavy. That's just going to add to the weight on the bank and could encourage failure later on. If they are using stone, we emphasize that they chink properly using appropriately sized stone. We don't like to have huge voids, especially in riverbank projects. If you get a good storm, the water will come right in there and take all of the stone out. We also like our towns to consider drainage. So if they have drainage on a project, we want them to try to put the drains towards the bottom. If they're putting it on the top of the bank, if they get a good storm, that can blow the whole slope out. Provide trees, add trees in there if possible. If you have existing trees, try to keep the trees in the bank. Again, those roots are really key for any slope stabilization project. If you are working around trees, watch where the roots are. Generally where the crown is, the top part of the tree, the roots will be there as well. So try to stay away from them if you can. Sometimes our foremen try to think that a wet hill means they need to cut all the trees off to dry it off. That may not be the case. Those roots may be holding that whole wet hill together. So look at different solutions you can use at the bottom of the hill. And for especially our riverbank projects, permits are likely required, so we encourage our towns to plan ahead and look at what's going on. So our culvert projects, this is probably our second most popular category, whether that's a replacement, an upgrade, doing inlet and outlet stabilization. There's a lot you can do with culverts. These are one of the items where they don't have the world's longest lifespan, but once they fail, it can be a huge problem. We try to encourage our towns to get a hydraulic study, especially if it's a 36-inch or larger culvert. The reasoning for this is bigger culverts tend to be huge failures if they end up being undersized. That's a lot of sediment that you're putting into the stream. When they're constructing projects, we like them to look at the bed profile. So what I mean by that is the bottom of the stream, making sure that they're creating a smooth bottom to the stream. They're not taking extra bucket loads out. What happens with that is if you take too many bucket loads out, the stream's going to try to flatten itself out all the way upstream, and it may pull hundreds of yards of sediment in for a couple extra bucket loads that were accidentally taken out with the excavator. Compaction and cover are another two things we really stress. One of the biggest reasons we see our plastic culverts in Vermont failing is people aren't compacting properly. It also can cause problems further down the line when the water hits the culvert. If there's no header on the culvert, it may end up going right around it, and then it'll blow the whole thing out, which is why we encourage headers and footers. That really prevents that high velocity water that's coming down from causing erosion around the culvert. It'll hit that wall and then hopefully go right into the culvert. With those headers and footers, there's many different options we have towns look at. They can go anywhere from just a simple stone header all the way up to concrete, and in between there's plastic headers they could use as well. Green stormwater infrastructure isn't something that's brand new for Vermont, but it's something a lot of our road foremen we find don't use a whole lot, so it's sort of a newer idea for a lot of them. A lot of them are trying to encourage the use of bioretention, rain gardens, those sorts of small items right now. We are hoping to incorporate it into a new Better Roads manual, which we are working on right now. We're hoping we'll have it out in the next couple of years here. And we really have them consider looking at maintenance on dirt roads. So do they have the correct equipment they need? Do they have the man hours they need if they're going to install a new practice? Are they educated on it? And looking at pretreatment as well. Obviously, dirt roads are going to produce a little more runoff, gravel, all of that stuff going into the system compared to a paved road. So it's a lot to look at. So cost is one thing they need to look at when they're building their project. Maintenance is another thing, really looking at the safety of the project, community perception and support, and importance of education and training. There's not just one thing they can look at here. So we'll get a little into the case study now. We'll look at East Thompson's Point Road in Charlotte. So for those of you guys who aren't sure, Plattsburgh is just to the north, Burlington is just to the north, and it's about 45 minutes south of both of those areas. So the surrounding area is in the Thorpe Brook Watershed. There's a neighboring farm nearby, the Mack Farm. Watershed leads directly to Lake Champlain, so it's definitely an important area here. The area really had a bigger sediment problem. There was a farm field that was going right into the ditch. They had eroding ditches. Obviously, with that, you have an overall sediment problem with nitrogen, phosphorus, and then sediment. The ditches were really overwhelmed. They had a farm field access in here as well that was really eroding. So when they looked at the project, there were a ton of different options they could use. They had to look at the surrounding land use, looking at the crown of the road. As Dana had mentioned, on a dirt road, crown can be absolutely essential to getting the water to drain off quickly. The ditches were obviously a problem. Culverts, they had different options they could use, and then looking at whether they could provide a treatment area as well. There were different options we discussed with the town as well, looking at their winter sand use, testing their winter sand. If you have winter sand, you don't want it to be too fine. That tends to muck up the road in the spring. At the same point too, you don't want anything that's too big either, because when you have big chunks of rock in the road, that can become a safety hazard. We had them look at whether they could do a grass or stone line ditch in different spots. Obviously, if it's not a steep slope, we encourage grass line ditches. Looking at check dams, turnouts, whether they could realign things. And then we had them look at stormwater treatment. So if they could put any settling ponds in or bioretention. And again, looking at the crown, culvert replacement, and then the final thing was altering the surrounding land use. Obviously, a farm field can be a big contributor to runoff here. So the solutions, they settled on a couple solutions here. One part of the project, they realigned the swale. One of the swales from the farm field was coming in at about a 90-degree angle, so they ended up putting it at about a 45-degree angle, so it wasn't hitting the road and the ditch and eroding both. They reshaped the grass swale where they could, made it a little bigger, a little wider to better accommodate the storms. They upsized the culvert and stabilized the farm access. The culvert was severely undersized and was causing pretty severe erosion issues. They stabilized the access so that if the culvert does ever overtop, that sediment won't be going all down the hill. It'll be caught in the stone. The stone shouldn't erode away. In areas where they had to, they used stone lining. They stone lined the swale and they added check dams in. Those check dams hopefully will prevent excess sediment from entering the stream. At the very bottom of the project, they use bioretention. So they have 3 small bioretention areas. It was pretty eroded in this area before, so now hopefully with the soils, they were able to infiltrate here and it should get rid of even more sediment. And then on the far right, some pictures of the town constructing the project. This really was a huge community project. They had a bunch of different watershed groups help out. The town did all of the construction. So they also hired an engineer to help with their design and construction support. They had the local farm nearby actually agreed to donate some of their land. They provided a buffer, and they actually graded their farm field so that it's no longer draining directly into the ditch and causing all sorts of erosion. And that's what we're talking about. If you have the space or you can get the space, definitely work with those groups. It's completely worth it. They worked with the Lewis Creek Association. They have a program called Ahead of the Storm where they try to reduce all of the sediment in these areas. And they had a bunch of different regulator agencies involved. So anywhere from VTrans to the Agency of Natural Resources and those sorts of groups. And the total cost of the project without engineering was around $35,000. So with a grant, it really wasn't too crazy expensive, and they were able to get all of this work done and prevent all of that sediment from going into the water. So with that, if you guys have any questions, my contact information is here. We have two other coworkers in our section, Linda Blash and Alan May, and they would be more than happy to answer any questions you may have as well. And with that, I'll hand it back over to Dana.
Thanks, Rachel. That was great. All right, show my screen. There we go. That was a really great presentation. Thank you so much. That was a very, very good case study. So as Rachel said, if you have any questions, go ahead and type them in the chat box on the right hand of the screen. I have a couple things that I kind of picked up on during your presentation and that I'd like to kind of highlight, and then I have a question for you. One of the things I picked up on was management. So sometimes we think of doing road erosion and all of these green infrastructure things as purely structural practices, things we can build, things that actually take water runoff. But one of the things that we need to think about is the management of the road or the parking lot or whatever it is. So talking about winter use and sand management, that's really key, because that can be a source of pollution in and of itself. Vermont is currently looking at a lot of regulations concerning chloride, so that's due to de-icing salts typically. So I think that that's something that we need to think about when managing for rural roads, or what are some of the non-structural practices that might actually alleviate some of the pollution issues that we experience. So using less sand or using a different type of sand, that sort of thing. So I was really happy that you highlighted that. I guess my question, one thing I noticed is one of your slides shows tires in the ditch, and I just thought that made a funny looking little check dam. I don't know if that was actually its intention or if those tires just ended up there, but I kind of like that. So anyway, my question now, Rachel, is this. It looked really great when it was getting installed, and I'm not sure how long it's been there, but how is it doing now? I mean, are these, have you been out there? Have you seen how the bioretentions are faring and the check dams and that sort of thing?
Sure. So this project was installed last summer, so it's been there for about a year now, not too long. The project fared really well. It's obviously not incredibly steep, so the town doesn't have to use a whole lot of sand in this area. The tires are no longer there, thankfully. Those were just there to block the farm field access so the local kids didn't drive around the field at night. There's a lot there. But yeah, it's definitely, in Vermont, generally we see these sorts of projects last about 8 to 10 years before they have to do any major maintenance on them, especially our stone-lined ditches. The bioretention areas, they should be going out every year or so and scooping any extra sediment out. But it's held up really well, and it's been a very successful project. The community's used it as a demonstration project, and everyone's very happy with it.
Oh, that's awesome. And it's good to hear that it's, it's holding up, and I think there's going to be a lot more research now on longevity of these projects. So hearing the initial figure of, 8 to 10 years seems to be about, your lifespan for some of the stone line ditches is really good. So Yeah, so I do not see any questions in the chat box. If you guys want to get in touch with either one of us privately, reach out. You've got our email addresses, I believe, or at least you had Rachel's there on the presentation. Mine is just Dana, D-A-N-A, at Watershed, C-A, as in consultingassociates.com. So I'm basically just going to wrap things up. We're getting on to the end of the webinar here. So what lessons have we learned so far? I think the basic takeaway from this is that, you know, managing rural roads runoff is important, in that protecting smaller sensitive streams from sediment and other pollutants is a big deal. We're sometimes in these very remote, sensitive environments where these roads are, and so paying attention to the fact that a smaller tributary can't necessarily take as much flow or sediment or phosphorus as maybe a larger pond or larger river. That's a very important distinction. So that's why it's so important to pay attention to how we manage these environments. And I think the other real big takeaway from managing rural roads like this is that it's not just good for water quality, it's also good for road durability. So if you want to protect your investment and be nice to the environment, luckily you can do that at the same time with a lot of these practices. So I think if there's nothing else you took away from this, those are your two key points, at least in my opinion. So with that, I'd just like to call your attention to our last two webinars of this series. The next one will be on, I believe it's Thursday, June 29th, from noon to 1, same time, same place in many ways. That'll cover parking lots and hardscapes, which is sort of one of the biggest landscapes that green infrastructure deals with. So that's going to be a big one, and Dave and Laurel are going to be presenting that. So they've got a lot of really interesting examples from New York, as well as some from farther abroad. So definitely tune in for that if you have the chance. And then our final webinar, we're going to take a little hiatus for the holiday. And our final webinar will be on July 13th from noon to 1. So again, use the information in the webinar to link in, and you can talk with me about building development. And we've actually got some super interesting examples from the Syracuse area, and there, I believe it's the Save the Rain program down there that's been doing a lot of interesting work. We'll have Madison Quinn joining us and talking about a massive cistern that the city of Syracuse has developed that actually feeds their ice rink with water so they can play hockey and whatnot. So June 29, July 13th. In closing, I'd like to thank the Lake Champlain Basin program again, Ryan Mitchell and Matt Vaughn, who couldn't be here with us today, for guiding this whole process, getting us the funding, and NUEPIC as well for getting us the funding. Dave and Laurel with Hirschman Water and Environment. And Rachel, I'd like to extend a special thank you to you for agreeing to do the case studies and putting together such a good presentation. So thank you very much.